Hello, my dear boys. Hope all of you are well by the grace of Almighty. Today we are discussing chapter 6. The name of this chapter is Effects of Heat on Matter. And today's our topic is creative question solution on this chapter. So let's calculate how to calculate or how to solution of a creative question on this chapter. So, boys, the stream of our today's creative question is when a copper sphere at temperature 30 degree Celsius is heated to the temperature 110 degree Celsius, its volume becomes 32 meter cube. Okay, specific heat of copper is 400 joule per kg per Kelvin and mass of copper sphere is 250 gram and the area of circular ring made of metal is 11.34 meter square. Okay, again, when a copper sphere at temperature 30 degree is heated to the temperature 110 degrees Celsius, its volume becomes 32 meter cube. Specific heat of copper is 400 joule per kg per Kelvin and mass of copper sphere is 250 gram and the area of circular ring made of metal is 11.34 meter square. Now the question of from this stream is question number A. What is regulation? B is specific heat of copper is 400 joule per kg per Kelvin. What does it mean? Question number C is find out the amount of heat. Find out the amount of heat gained by copper copper sphere. And the question number D is if there is no loss of heat energy, will the heated copper sphere go through the metal ring of the stream? Analyze with logic. with logic. This is our questions. Okay. The question number A is, what is regulation? Okay. And question number B is, specific heat of copper is 400 joule per kg per Kelvin. From our steam we know that. The question is, what does it mean? Okay. Then question number C is, find out the amount of heat gained by copper sphere. And question number D is, if there is no loss of heat energy, will the heated copper sphere go through the metal ring of the steam? Analyze with logic. Okay, then we will go for our answer. The solution for A is what is regulation? To melt a solid substance melt a solid substance into liquid by applying pressure and again and again to bring it back to the solid state by reducing pressure is called regulation. Okay, to melt a solid substance into liquid by applying pressure and again to bring it back to the solid state by reducing pressure is called regulation. Okay. Then our solution for question number B is the question number B is for two part. The number one part is for this type of question we need to firstly we need to write the definition of specific heat, and then we need to describe what we means for the specific heat of copper. Okay. Now the amount of heat question number B, the amount of heat is required to increase the temperature of a body of mass 1 kg by 1 Kelvin, 1 Kelvin is called the specific heat. The amount of heat is required to increase the temperature of a body of mass 1 kg by 1 Kelvin is called the specific heat. So, by the specific heat, so the specific heat of copper of 400 joule per kg per Kelvin means that the amount of heat. So here we can write 400 joule means that 400 joule heat is required to raise the temperature of 1 Kelvin temperature of 1 kg copper through 1 Kelvin. Okay, so this is our knowledge part and this is our explanation part. Okay, the amount of heat is required to, in our knowledge base part we can write the definition of a specific heat, and that is the amount of heat is required to increase the temperature of a body of mass 1 kg by 1 Kelvin is called a specific heat. So specific heat of copper 400 joule per kg per Kelvin means that 400 joule heat is required to raise the temperature of 1 kg copper through 1 Kelvin. Okay, then the question number C. Solution for question number C is, here we are given that the mass of copper M equal to 250 gram, 0.25 kg. We need to convert it to kg. Then we are given that the difference of temperature del theta equal to theta 2 minus theta 1 equal to 110 minus 30 equal to 80 degrees Celsius, or we can write, because this is the difference of temperature, so we know that the difference of temperature in Celsius scale is equal to the difference of temperature in Kelvin scale. So we can write 80 degrees Celsius equal to 80 Kelvin. Okay, and here the specific heat of copper is equal to 400 joule per kg per Kelvin. Okay, now we know that the heat required, the amount of heat, the equation of gain amount of heat is Q equal to ms del theta. So we can write 0.25 into 400 into 80. By calculating these values, we get the answer is 8 into 10 to the power 3 joule. This is our required heat and heat that gained by copper sphere. Okay, so we can write heat gained by copper, heat gained by copper where sphere is 8 into 10 to the power 3 joule. Okay, this is the calculation for question number C. Now we will calculate the question number D. So to solve this question number D with logic, we need to calculate the radius of the copper sphere and radius of the copper wire, okay, or copper ring. If the radius of radius as well as diameter, so radius of copper sphere is less than the radius of copper ring, then the copper sphere will go through to the copper ring. If not, the copper sphere will not go through the metal ring. Okay, so we need to determine the radius of the copper. We need to calculate the radius of the copper sphere and need to calculate the radius of the metal ring. Okay, so for this we have a clue here. After increasing the temperature, we see that from steam we see that the volume of copper sphere become 32 meter cube. So according to the formula of the volume, we know that it is 4 by 3 pi r cube. So let the radius of copper wire copper sphere is, let the radius of copper sphere is capital R. So we can write, according to our steam, we can write 4 by 3 pi r cube equal to 32. By calculating, we get R equal to 1.969 meter. Again, here given that the area of metal ring is, the area of metal ring is equal to 11.34 meter square. So we know that the formula of area is pi r square. Let the radius of metal ring is small r. So we can write pi r square equal to 11.34 meter cube square. So from this we get the r is 1.899 meter. So we can see from our solution that the after heating, the radius of copper sphere, radius as well as diameter. Okay, so radius of copper wire copper sphere is 1.969 meter, and the radius of metal ring is 1.899. So we see that the radius of copper sphere is greater than the radius of the metal ring. So we can say that the copper sphere will not go through the metal ring. Okay, so we can write that, but we can say that the radius of copper sphere will not go through the metal ring. Okay, this is all from today. In our next class we will try to start a new chapter. Until then, thank you.